All right, so hopefully you're in the right room. This is about using Lua with Wireshark. My name is Hadriel Kaplan. I used to be with Oracle, before that a company called Acme Packet for many years, and then before that a company called Avicii Systems, and before that Nortel Networks, Bay Networks, Wellfleet, University of New Hampshire, and so on. So I'm one of the, I guess technically I'm one of the core developers, but I don't spend nearly as much time as most of the other guys. I focus mostly on just the Lua API for Wireshark in terms of expanding the Lua API, which I haven't done much of in the past 6 months or so because I've joined a startup, and startups just consume all your time. But I do, hopefully we'll get some more time this summer to work on expanding even further than it is today. But this is trying to cover most everything through 1.12, and then some of the new things that are going to show up in 2.0, or hopefully will show up in 2.0. So I'll start with some questions for you, first of all. So how many of you have attended the Lua workshop last year, 2014? Okay. So half the slides will be boring to you because they'll be very repetitious. The other half will maybe be completely new. And how many of you have actually written a Lua plugin already for Wireshark? One. Good. How many of you know Lua the language? Or at least, yeah, this is actually pretty good for Lua, by the way, like this type of answer. And how many of you are in the wrong room right now? No. Excellent. So resources. The truth is, a lot of the stuff I cover is already available on the wiki site for Wireshark. Now, I know it's very hard to figure out which specific pages they are because the Wireshark wiki site is not the best in terms of navigation. But if you have any suggestions for how to improve the navigation, you can actually register yourself and make the changes yourself in the Wireshark wiki site. But you should know those URLs at the top because they are really the pathway to most of the resources about the Lua API and writing Lua scripts in Wireshark itself. There is also the ask.wireshark.org website, which is a reasonably good but not perfect place to ask questions. It just takes time. Most of us aren't, it's not our full-time job to work on Wireshark stuff. And I know personally I get into these spurts where I'll answer like 20 questions in a row, and then I'll disappear for a month, and then I'll come back and answer another 20 questions. If you need something answered like super duper very quickly, well, do that. Google, I guess. Google the questions. Because the truth is most of the questions have been asked before already. Very few are new questions. And then for Lua itself, there's a bunch of websites. There's also, of course, books as well, even free books online on how to write Lua. You don't have to be a Lua programming expert to write Lua for Wireshark. Most of what Wireshark does is pretty simplistic, does not require advanced Lua knowledge. Of course, if you have it, that's great, but otherwise, you don't need it. So the agenda for today is going to be a quick introduction to Lua. This is not the class. Let me actually kind of step back and explain the point of this workshop. So we only have an hour and 15 minutes, which is not nearly enough time to either train you on Lua, the programming language, nor truly go through everything you could do in Wireshark with Lua, nor really go and get into the nuts and bolts of how to write even just one type of script. We are, however, unless you guys don't want to, and part of this class, if you guys have deeper questions or whatever, please feel free to raise your hands at any time. But we will go into a dissector script example. It's going to be a simplified version of something that's already available on the wiki, but the way I'm going to go at it is very different from the way it is on the wiki. And so we will get into an actual dissector script because that was the title of this session. I know on the agenda it had a slightly different title, but on the agenda it said this was 3 sharks, which was supposed to be in advance. But on the website it says 2 sharks, and the truth is it's really 3 sharks, I think, or maybe 2.5. I don't know the number of sharks. Laser sharks really is what's the important part. So what we're going to go through. Actually, let me go back. So we're going to go through an introduction to Lua. What can you do with it? Not in general, but in Wireshark, obviously, and in the particular instance of Wireshark. And then we're going to go through the basics of a script, the dissector script in particular. You can do a whole lot of things with Lua and Wireshark. Not just dissecting, by the way, means decoding of a new protocol. You can do a lot of things that have nothing to do with decoding of a new protocol. But that's what, a large, I don't know about a majority, but at least a large minority of people do. Probably the biggest group of people use it to decode a new protocol. So that's what I'm going to cover today with a small dissector script. Because of the time constraints, I'm not going to start with literally a blank page and start typing out the script because it would just take too long. So instead, I'll show you the script. It's all visible on one screen, maybe even with this resolution. I don't know what the resolution is on this projector, but hopefully it is. And we'll go through it line by line, and I'll explain what it's doing and why it's doing it. Then we're going to go through what's new in 1.12, which is out now, as well as what's coming or may be coming in 2.0, depending on when 2.0 ships. Right now, the development release 199, and presumably the next one will be 2.0. And it all depends on whether I get things in soon enough or not for them to show up in 2.0. So, Lua itself, if you haven't heard of it, you should have by now. It's I'll sit for most of this because I've got a lot of taking to do anyway. It's a small but powerful scripting language. It's extremely small in terms of C code, the actual engine itself, less than 200 kilobytes. It's very simple language, simple to learn, but very powerful. If you know other scripting languages like JavaScript or Go, it's quite similar to some of those, not with nearly as many libraries built in, but from a pure language perspective, it's pretty similar to those, as well as even to Python in some degree. It runs on anything because it was written in pure ANSI C, so it runs on anything that can compile C code. Doesn't do anything fancy under the hood. And it's very popular plugin for embedded systems. For gaming, the game world, Lua is actually probably the predominant plugin language, mostly because World of Warcraft started it. There's even an entire book you can buy at Barnes & Noble and Amazon about programming World of Warcraft. World of Wireshark, yeah. World of Warcraft with Lua. That's what we need. We need an Easter egg game inside of the Wireshark. It's been popular in that world for a long time. It's also available in a lot of other random things, databases and stuff usually have plugins using Lua. There are other competitors as well, of course, but I don't know why Wireshark chose it originally, but really there aren't that many choices. Mostly it's Python, JavaScript, and Lua. Some people are using Go now. I think once their garbage collector is better, maybe more popular. Unfortunately, they seem to have decided that tab character is super important, and that was a horrible mistake on their part, so I would never use the Go language. But we may add Go to loop to Wireshark at some point in the future if it truly turns out to be useful. There was a Python API, so Lua wasn't the only one. There was a Python API for Wireshark a while ago, like 3 years ago, but it wasn't maintained, so it's actually been removed. If you want one, you can go back in the Git tree, although back then I think it was actually in Subversion, but it's in the Git tree anyway. You can go back in the Git tree, find it, bring it back, and try to make it work again. Good luck with that. So why did we pick Lua, or why is Lua being used versus C? It is easier and faster to learn than C by far, obviously, as a language. A lot of people who write these plugins for Wireshark are not programmers in their day job. The other nice thing is you don't have to compile Wireshark. If you've ever tried compiling Wireshark, I'm really sorry for you. It's a massive pain in the ass. And I don't know how to make it any easier. There's about 30 libraries or something it depends on, and it supports 5 different styles of make files, and it's just crazy. It's extremely complicated because it tries to be universally applicable to every type of user and platform. So that makes it very hard. So the nice thing with Lua is you can just distribute your script or your decoder as a plugin instead of having to wait for the next Wireshark release. The other nice thing is, as an API, Wireshark does have a C API. You can write in C code a plugin that loads dynamically and uses Wireshark, but that API is not stable. What I mean by that is every release it changes. So you have to rewrite, change, or recompile your plugin for basically every Wireshark version, which is super annoying. Whereas with Lua, while it's not guaranteed to not change, it has not changed in many versions. It's increased. In other words, there have been more things exposed into it, but the existing API calls that you use, the scripts you've already written, should continue to work. If you wrote it back in 1.8, it should continue to work in 1.9, 1.10, 1.11, 1.12. That should also be true of 2.0, except that we're looking at supporting Lua 5.3 in 2.0, and that may pull out the bidop library, and I'll talk about that at the end. Or I may just change the bidop library so it works with Lua 5.3. I'm not sure how many people really use the bidop library anyway. It's a particular library that's available. So anyway, those are the good reasons to use Lua or write a Lua plugin. The bad reason, so why would you not write a plugin in the Lua language for Wireshark? Number one reason is support for bug fixes. If your Lua plugin has a bug, you have to fix it. Nobody else is going to fix it for you. Whereas native C dissectors, if you write a C code-based protocol decoder and submit it to Wireshark in Git, or really through the Garrett website or the Garrett site for Wireshark, and if it gets put into the main line, that decoder that you wrote will actually be supported by other developers, not just you, in the future. So if it breaks, it'll be fixed. Or if somebody finds a problem with it, it can be fixed. And you don't have to be responsible for doing that. The other reason not to do it is there is no central repo for Lua scripts. They're not included. There are no scripts included except for the init.lua script. But there are no protocol decoder scripts included with the Wireshark release. So you have to provide them to your own users if it's somebody else you want to use the decoder. Now, generally, that's actually not a problem at all. Most people write decoders just for their own company, for a protocol, a proprietary protocol they wrote. Generally, if it's a widely used protocol that's non-proprietary, or even if it's proprietary but at least known to be used outside of that company, then Wireshark developers will eventually create a C code-based one anyway. But certainly for prototyping, it's a lot easier to do it in Lua. The other reasons to write it in C code as opposed to Lua is C code is faster. Whether it's a lot faster or only a little faster depends on exactly what your decoder does or what your Lua script does. And of course, it depends on what your capture file looks like and everything else. There's a lot of variables, but generally it is faster to write in C for the C code compiled versions of decoders. And C code can still do some things that Lua cannot. I'm trying to make that as small a number of things as possible, as few things as possible, but I can never keep up really with all this, what C code can do. And then of course this C code compiled version of Wireshark is distributed from wireshark.org, so anybody can get it for any number of platforms, Windows, Mac, Linux, etc. Now a Lua plugin can run on all those platforms as well. There's nothing special you have to do. Once you write a Lua script, it runs on any of the native platforms that Wireshark supports, so that's a good thing. But you have to put it on some site, some way, send an email, whatever it is, you have to distribute that plugin to other people. We don't include that in any repository today. We may add, or you can feel free to add a wiki page to have your own script. In fact, there are a lot of example scripts on Wireshark's wiki pages, but it's not an official repository, so to speak. So what can you do with the thing? What kind of things can you accomplish? One is protocol dissectors, or what we call dissectors. Again, it's a decoder or protocol parser. So when you have a new protocol, a proprietary or even a new standards-based draft, whatever protocol, and you want to decode it, if Wireshark doesn't already do that for you, you can write your own. And that's probably the most popular thing to do. You can also generate custom stats and counters, keep track of whatever you want, display it either in the GUI or write it to a file or write it out to the command line if you use T-Shark instead of Wireshark, for example. You can perform expert analysis. So expert analysis in Wireshark, if you haven't used it before, it's really just part of the protocol decode. When you go through, you'll see in some cases where I'll tell you things like TCP retransmissions or missing packets or whatever will be listed as expert information in the protocol decode fields. And you can add your own with Lua plugins. Then you can save packets to PCAP files using any custom criteria you want. So for example, you could write a plugin that only saves sent packets to a file but not received, or maybe sent to one file and received to another file, or maybe sent packets to a certain address or a subnet, and then split those out by files. In fact, one of the example scripts on the wiki pages is to save separate files for each IP address range for packets received by Wireshark. You can add new GUI menu items for actions as well. When I say GUI, by the way, I'm talking about the graphical user interface. And generally, I'm talking about the GTK-based one, which, if you don't know, is the old one, the one that you see in every release since, Ethereal 1.0 or whatever, or 0.99, or actually before that too. So it's been the GUI that you see through everything. In fact, I can switch to. I don't know how. That is the GTK-based GUI, as opposed to the Qt one. If you go to the newer releases, the 1.99 development release, you'll see a new GUI based on the Qt framework, which is a lot prettier, I guess you could say, nicer looking, but it's missing, currently missing, the Lua GUI APIs, meaning you can't do things like look at the console or run things through Lua or add your own commands, at least not yet. That's one of the things that I'm hoping to get in for 2.0. Yeah?
Is there a Lua debugger?
Is that, sorry, what?
A Lua debugger?
Is there a Lua debugger? No.
I missed that a bit.
What's that?
I missed that.
If, you know, yeah, generally you can of course put debug statements and use the debugger that's in Lua itself as a Lua library for debug. And when there are failures through the API, it generally tries to tell you what they are. Either through a dialog box that pops up or through a string output on the command line if you use T#. I'm not going to say they're 100% useful. Sometimes they're a bit cryptic as to what the problem is, but I've found them to be pretty, at least I've tried to make them be as informational as possible to help. And of course, ultimately, you can do print. So, the classic debugger of most programmers, is to print out variables or state at any point in time in their program. And then you can, which is really new in 1.12, but you can read and write from and to custom packet file formats. So really this means any file format you want, not just PCAP file formats, or not just the file formats that Wireshark natively supports, which is a lot more than PCAP, right? It supports net X-ray format, sniffer format, HP, WNG, a whole baloney list, a huge list of Wireshark, of capture file formats. And you can create your own. So if you work for a company that's written its own version of a capture file format, or in my case, one of my previous employers dealt a lot with string-based protocols, SIP, a VoIP protocol that happens to be similar to HTTP or SMTP. And it's string-based ASCII encoding or UTF-8 encoding inside of the messages. And so they saved those UTF-8, those ASCII, basically, text strings to a text string-based file. And it wasn't a true capture file format in terms of not having an IP layer and a bunch of binary information, but it had that representation in ASCII. So I wrote a Lua plugin that was able to read that log file effectively and display that as packets inside of Wireshark and run everything else as if it was a PCAP file format in Wireshark. In fact, you could save then that file to a PCAP format if you wanted to. And that example script is in fact on that script is in fact on the example site on the Wireshark wiki. And then you can load log files and view entries as frames too. This isn't necessarily the best tool on the planet to use for log file analysis, but some log files really lend themselves to a Wireshark type interface. Mostly because the nice thing you can do with Wireshark for log files is once you have fields, in other words, those display fields that you can put into filters, you can then filter out the output and show just the log entries that you want, for example, using those fields. Again, there are plenty of other tools for log file analysis, but using Wireshark in one is not a horrible idea. And lastly is FileShark. FileShark is not really a product yet, as far as I know, but it was the idea of using Wireshark to view other file formats and decode them as protocols. So for example, if you have an MPEG file, which has a whole bunch of, it's a video file, right, MPEG video stream, and it's really contains a bunch of the equivalent of packets or frames of video frames and audio too. And so if you wanted to open that file and view it as the metadata, as the actual formatting itself, as opposed to just viewing it to play the video, which is, you can already use QuickTime or RealPlay or whatever, and you can use a bunch of other tools for that. But if you wanted to just decode the actual contents of the binary file and tell you what the individual fields were, why not Wireshark to do that? And you can do that with Lua, because you can have Lua Plug-in load that file and decode them as a new protocol, and voila, you have yourself a FileShark. So, any questions so far? Yes?
Can you mark packets?
Mark them at the equivalent of right-click marking?
Yeah.
No.
Or add a packet comment.
Yes, you can add a packet comment. Yeah. That was new in maybe 1.12, I think. If you actually go to these, I need a faster way to go through backwards for this. If you go to that second URL there, Lua API changes there, it actually shows you which things have gotten exposed by different releases, and that one I think was in 1.12. So yes. All right. Any other questions so far? because now we're going to get into the actual life of a Lua script. We're done on time. We're actually good. All right, so the life of a Lua script in Wireshark. When you start Wireshark, as I just did a minute ago, the following happens as a very simplified view. The C code-based code, compiled code, initializes most of the native code names, including the native protocol dissectors, the native taps, starts up the GUI, etc. It reads and executes the Lua scripts after all the native protocols and taps and everything else have already been loaded. It then registers the tap listeners, both native ones as well as Lua. It reads the preference file. So if you've used Wireshark for a long time and you've changed things in the GUI or you've changed some of the default settings or whatever, you've probably edited the preference file whether you meant to or not. And especially if you went into like the edit preferences field window and started to click on a lot of toggles or change the default port numbers or whatever, there's a native preference file that gets read in when Wireshark starts up. And Lua scripts can have their own preferences as well. They can add to that list that's available in edit preferences. They can add their own protocol information in there. They can be saved to that file, and they can read that. The Lua plugin itself can read what the user has set as their preference so that they can use that preference instead of whatever was hard-coded in the Lua plugin. Of course, when I say it was hard-coded in the Lua plugin, the user could also just go into the Lua plugin and edit that value in the Lua plugin since it's just text anyway. They can do that there, but obviously it's a little nicer if they don't have to know anything about Lua. If you're trying to distribute this, most of the way I think of this is, working for a manufacturer of equipment or a vendor of software or hardware. I work on the engineering side, and there are a lot of salespeople, sales engineers, systems engineers, support people. And so if I want them to be able to decode proprietary information inside of our product, I send them the Lua plugin to use with Wireshark. I don't expect them to have to go and change that Lua plugin. So I try to make it use Wireshark as much as possible, as if it was just native Wireshark features. And then it parses the command line arguments. And actually, I think this got changed recently, that it may parse the command line arguments before the preference file. I can't remember. It was a chicken and egg problem we had with Lua, where because we can pass preferences in the command line as well, but in the command line, you can also specify which Lua script to load. And so it needed to do that much earlier. So I think actually this got changed, but it doesn't really matter for most of the stuff we talk about today. In terms of those Lua plugins, there's really two ways of getting a Lua plugin loaded by Wireshark today. In the future, we may be able to load them dynamically, even at runtime, from like a menu item or whatever. I don't know if there's plans to do that. I know one developer was working on making Lua plugins dynamically loadable in Wireshark. Today they're not. What I mean by that is when you start up Wireshark or T-Shark, when you start up either of those programs, whatever Lua plugins they start with are the Lua plugins they're running. And there's no way to unload them. There's no way to load up new ones after they're running. You have to basically shut down Wireshark and start it all over again. Generally, that hasn't been a problem in terms of a limitation. At least it never occurred to me that was a limitation. It's annoying when you're developing the Lua plugin because you have to keep starting and stopping and starting and stopping as you're trying to debug it because we don't have a debugger. And so it's a little annoying in that perspective, but that's for the developer. Once it's running and working, it's usually not a big deal for most users that it's running whatever it's running. But another developer for Wireshark decided that they wanted the ability to dynamically load them, so they're working on that. I don't know how far he's gotten, but that may be coming in 2.0. But the important thing is that when Wireshark comes up, it actually invokes or loads up a Lua script that comes with Wireshark called init.lua. And it's in the global configuration directory. And if you don't know what that is, if I actually go back to here, was I already running Wireshark? Yes, I was. When you start up Wireshark, if you go to About Wireshark, and in the Folders section, you'll see there's a bunch of folders that Wireshark uses internally. One of them is the global plugins, another is global configuration, and personal plugins too. Those directories have various things that are pretty important for Lua, and one of them is this file called init.lua. And the init.lua file has a bunch of settings that are applicable to Wireshark that you should not change. In fact, really you should not change the init.lua script at all, except for two variables, which are inside of it to disable Lua itself. If you don't want Lua to run, there's a variable inside of init.lua that lets you disable it. I know that seems a little weird because it's in a Lua file, because the truth is Lua is running. There's no way to prevent Lua from running when Wireshark starts. But you can prevent it from loading any actual plugins other than the init.lua one. And the way to do that is to set a specific variable to true.
Hey, what's the bit with Lua in Linux running as root? Because there's error that pops up, and it's obviously in the global config.
Yeah, so there's a variable. In fact, I'll switch to the. Sorry.
What do you have to change?
Yeah, I'll switch to the. Where is the? Yeah, that's an interesting resizing. Does that show up? Excellent. You guys ever used Sublime Text? It's awesome. It's so much better than any other editor. There is a single variable here called run user scripts when super user. By default, false. What that means is if you are not root and you run Wireshark, it will not load up those other scripts because it's running as root and it would be dangerous. If you set this to true and you restart Wireshark, it'll then load those scripts.
Okay, great.
For most people, this isn't a problem, but yeah, I recognize it. It's annoying. We should probably try to make this like a GUI thing eventually to make it a little easier than having to go into this file to edit. But the other one is the variable I talked about earlier, disable Lua, how cleverly named, okay. Which is false by default, but you can set it to true, which means Lua's disabled, period, no matter whether you're super user or not super user. Okay. Good. All right. No questions. All right. Then it actually loads a file which usually does not exist, but if there is in your personal config directory an init.lua file, it'll load that file. This lets you have initialization information just for yourself. Very few people actually ever use this feature, and what you should actually not do is copy the init.lua from the global config to this config because they're different files altogether. We'll talk about that in a minute anyway. Then it loads all the Lua scripts that are in the personal plugins directory. And as you saw a minute ago, man, switching to this is kind of annoying. Personal plugins, which is in this directory here. I don't happen to have any on my machine here, but this is where you would normally put your Lua plugins if you wanted them to load every single time when you started Wireshark. Personally, I develop scripts more often than I use them myself, so I load them through the command line. Which is done, if it says in here, with the -x option. There's a -x Lua _script : and then the name of the file, and that'll load it from the command line. You can use that command option with either Wireshark or T-Shark. You can even pass your script actual arguments themselves, which is a new feature in 1.12. Also using the -x Lua script. And if you want more information on that, I can tell you. But again, it's mostly used just for testing. Once you have a finished Lua script that's working and it does what you want it to do and you want to give it to other people or even use it yourself all the time, normally you just put it in the personal plugins directory and it loads every time. Now about that init.lua file. As I said, don't muck with that file. Other than those two variables, which are okay to go modify, pretty much everything else you should not touch whatsoever. The reason is it actually sets a lot of variables that are needed at runtime by Wireshark. And the truth is that if you edit them and you upgrade Wireshark, it gets overwritten anyway. Or at least it should be overwritten. And so you should not be changing those files. And the one in your personal configuration directory should not contain the same variables or information as the one in global config. So don't just copy the file over. The reason is because that one's loaded second. So as a Lua programming language, if you have a variable named foo and it's set to true, and it reads another script that says foo = false, it'll now be false. It's a global variable. Most of those variables in those two files are global variables, not local to the file. And so if you upgrade Wireshark to version 2.0 or whatever the next one is, it'll change that global one, which is read first, but your secondary one is still going to be read, and that's not a good thing to do. Because now, if you were to set those other variables, you'd screw up the main Wireshark program, which had already changed them in the init. So the moral of the story is don't muck with init.lua. All right, so now the basics of the script. I don't know how easy it'll be to switch back and forth. but we're going to try. So inside the script, as I said, the Lua script itself is executed during boot up of Wireshark today and not dynamically after it's already running. But the things that it actually does in terms of decoding packets, for example, or dissecting packets, or listening taps, or doing whatever, don't happen, of course, till much later. I mean, when you load the Lua script, you don't have a capture yet. You don't have any packets yet. And so it doesn't make sense to do those things yet. And so the way that most things happen is that the code is loaded and read and executed, technically, from Lua perspective. But most of the code is actually just creating functions. And those functions are then registered as callback hooks in Wireshark itself. And Wireshark later invokes those functions at the right times. Like when it receives a packet, it'll then invoke a function that you've created in Lua. It's already technically executed the Lua script in terms of loading it and technically executing it, but the execution of it really just resulted in the function being created. So for example, why is it not working? For example, this is a listener tap script. Super, super simple listener tap. It's based on one that's an example in the wiki page. If you look at the top of it, can you guys read that? Yeah, pixelized. Sorry about that. It's too bad because Sublime Text is one of the nicest looking editors around. It's just not doing well with this resolution on the screen. If you look at it from a Lua language, and you don't need to understand Lua very well right now. If you actually go and write plugins, well, yeah, you're going to have to go in RTFM, right? You're going to have to read the actual Lua documentation for what the Lua language does. But the top one sets a variable. It creates a local variable called packets. It sets its value to 0. Lua, like JavaScript, actually, how many of you have ever written in any scripting language? JavaScript, Python, Go. Okay, good. We have to start it like, here's what programming is. So like all those, the variables are dynamically typed, and they're changeable at runtime, and it's a true scripting interpreted language. So it runs the equivalent of a JVM style machine language in the background. So when you load the script, it compiles those words into instructions that have meaning to a virtual machine execution environment, as opposed to compiling them to actual assembly code. And so when it's running, it just executes those instructions. And just like JavaScript, just like Python, just like Perl, just like Go, just like whatever other scripting language, Tickle, whatever else you can think of. So the second one also creates a variable called tap. And in this case, it's going to set tap to whatever returns from a call to new, which is a function of the table called listener. In this case, Lua is kind of being used in object-oriented style. Listener is really a class name, effectively. New is a method call that's a static method, so it's really a static function call as opposed to a method style. And it's taken a couple arguments. One is a string called IP, or contents of IP. Another was a string that looks like a display filter or capture filter in Wireshark format. In fact, that's exactly what it is. What that second line does is it creates a new listener object with the arguments for IP and the argument for a display filter. I'll discuss those a little bit I think in the next slide. But right now I'm just trying to get used to the idea here. Then it creates a function. Now, it's not actually executing the function. Now, in this case, the function is called tap.reset. The real function name is reset, and it's a member of the tap table, the tap, our object. And the tap object is really the name of the variable that was right up above, which was local tap equals listener new. Listener new creates a new object that's going to be set to tap. So tap's a variable name. Variables can be strings, numbers, functions, or tables. And in Lua, tables can also be used in an object-oriented style, which is what this does. So that tap up above got set to some object created by the listener new function. And so now that object has various functions that are available, or really table entries that I can set to functions. In this case, I'm creating a function which all it does is set that word packets to equal to 0. The reason for this is that the reset, as well as packet, as well as draw, which are those three functions you see there defined, those are well-known function names of the listener object in Wireshark. If you go into Wireshark's wiki API, and you look up the listener, and in fact, I'll do it for you right now, because a lot of people have trouble understanding the API for Wireshark. If you actually go to the website, and go to listener, This is what the API documentation looks like for listener in this case. Actually, if you want to start from the beginning, most people start from this page. This is the main Lua page in Wireshark. It's full of a bunch of stuff that you'll never read a second time. And instead, you'll go down to one link that's hidden under the word here. It's like Easter eggs. And you click this link. Oops, let me just click it here. I do have wire. And then you'll go to chapter 10. Oh boy, this is bad. Chapter 10 is actually useless, so we're going to go up one. Sorry. I'll have to fix that URL. Or you can do it. And actually, the better one is chapter 11, which is the true API reference manual. And in chapter 11, you will eventually find listener right here. That listener new is that function we called earlier, which creates a new listener object. And down below, you'll see that there's a listener packet, a listener reset, and a listener draw, which are all functions that you can assign to the listener object. And Wireshark will invoke those functions later on. So it'll invoke them at certain times. Reset happens to be done at the end of a run through a capture file, or in T-Shark at the end of the run of the singular capture file. Packet is executed every time a packet gets seen by Wireshark, or captured by Wireshark. Or if you open up a file, it's for every packet inside of that file, or frame really we call it, but it's called packet here. And then draw happens to be executed actually multiple times, usually either in the GUI or in T-Shark it only gets executed once at the end of the file, but in the GUI it gets executed a bunch of times. Invoked, in other words. So Wireshark will actually invoke that function later on. All this script does is really define those functions, but it doesn't actually invoke them, right? They're not actually being called. So when Wireshark starts up with a script like this, it loads all these things up, but until it actually sees a packet or until it's done with a file or whatever, it won't actually invoke these functions. Any questions so far? Yes?
What's the significance of the first argument to listener new?
Excellent question. If you read the API docs, which I just did this morning, just to see what they said, you will note that they say something like listener name or something completely anonymously bogus, right? It is actually a name of the listener type, which there are only a certain number of listener types that you can create. Generally, people put in the word frame there instead of IP. Frame means that you're tapping into the frame. In Wireshark parlance, a frame is a packet for most of us. If you open up Wireshark and you see there's a list of packets, those are frames technically. And if you actually click on the actual, let's open one. If you look through here, you'll see that the very first thing is actually the word frame. And if you expand that, you'll see it has much of meta information about that entry in the capture file in this case, or in a real live capture if it's capturing. Some of this stuff is generated like this. It's not actually from the frame itself. Others tell you the metadata about it, like the type of encapsulation inside, the length of it, and so on. This frame really encompasses all the rest of the data. Then you'll see Ethernet, which is an actual packet, as well as an IP packet inside of that, a UDP packet inside of that, and some random data. Yeah?
With Lua act on reassembled frames, so if there are multiple people in the GUI, you look at reassembled.
Right. We will actually be covering, if we have time. Wow, this class is going fast. There's actually, I will cover reassembly a little later. I wish it were easier. It's not easy. It's also not easy to write in C code either. There are some facilities that try to help with reassembly, TCP reassembly usually. And Lua can take advantage of some of them, but no matter what, it's just painful to write a protocol decoder when you have to take reassembly into account. But I will talk about it later. When you do a listener for a frame level, really you can almost think of this thing as like the level that I want to listen at. So if I do this at a frame level, every one of those entries in there will invoke that listener object's packet function, which is that middle one. Whether it's reassembled or not, doesn't matter. The reassembly happens at a much higher layer, so to speak, usually a TCP layer, or SCTP or whatever. But for the frame layer, it wouldn't be. The same with IP. Each of those is a separate IP packet. So even with reassembly, well, I guess there could be fragmented IP packets, but I believe it's still called for each one, even with fragments, because they each have an IP header and really invoke the IP dissector. But for UDP and TCP, if it is an IP layer fragmented packet, they'll only get invoked for that one layer that's called above them.
If you want to pull out monologues and those certain conversations, because those are typically reassembled, Pakistan, would you be able to do it with Lua, or you have to keep track of all you have to do the reassembly in Lua and then...
It depends. If the protocol, for the microphone, the question was if you have two sides of a conversation, which is pretty common, and it needs to be reassembled, do you have to do it do you have to write that reassembly in Lua, or is it done for you under the hood? It depends. If you're just doing a listener tap on a TCP layer, actually that reassembly won't be done either. But if you're doing it for HTTP, for example, or the number of sadly, the number of tap types you can do is actually pretty limited. In fact, let me take you to, is this showing up? Excellent. In fact, I just happened to be checking out which ones they were earlier today. There are only IP, UDP, HTTP, and then VoIP protocols like H225, and then there's 802.11h, there's a TCP layer one. These are the only ones you can actually usually do it for. But I'm having trouble switching.
But if it's one of these higher ones, then you have reassembly built in, so tapping in on after the reassembly, or not? If you take HTTP...
Yes, if you're handling a higher one, if you're listening on a higher level one, then yes, you won't get invoked until the higher level one has decided to invoke you, in which case it's already been reassembled. Hopefully.
Yeah.
It all depends on the C code, unfortunately, under the hood for them, though. I mean, it's how the programmer wrote the dissector for those. And they're the ones deciding to invoke taps. Lua is not the only one that has registered listeners. There are other listeners that are written in C code, listener taps, that are written in C code that are also, I meant to go back to this, that are also getting invoked, and the C code just does it at a specific point in time. So like for SIP, for example, there's a listener, and that does get invoked, I believe, when there's a whole message. Yeah, because it looks for the length field to determine length first, yeah. So then in that case it does. Sorry, it's dry. You Westerners with your air conditioning. So Wireshark knows to call those functions later, as I said, because they're registered. Now sometimes they're registered because they're part of something like that listener tap where it's a pre-known function name and Wireshark knows to go and call it. Other times you create a function and you actually register it with a specific function called register something. Like there's one called register heuristic if you create a heuristic dissector, or register post dissector if you create a post dissector. So those are explicitly named ways of registering. If you've ever written in a programming, in a scripting language for other applications like World of Warcraft or other tools or whatever, you'll find that there's a big variance about how they do registration of callbacks. Callbacks is almost the universal way that everybody does scripting language support, but just how they're handled is not consistent, and I'd argue that Wireshark's is a little inconsistent internally as well, because it just seemed easier to do things in some ways and then others at different times. Now we've already gone through listener taps to some degree. I don't want to spend too much time on them because the idea today is to go through dissector, which is not a listener. But I will say that listener taps are probably the second most popular thing to do after dissectors with Lua plugins. They're really meant as like effectively a read-only version of dissection. They don't let you dissect a new protocol. You can't add new fields into Wireshark. You can't change the GUI. You don't add new columns or any of that stuff. Stuff you can do with dissectors you can't do with listeners. But if what you want to do is look at statistics or do some later on analysis or whatever, listener taps are all you need to do. And they're a little easier to write because of that. The other cool thing, as I kind of showed in that example, was you can actually apply display filters. So, for example, with this, we're in trouble. With this listener tap, this is a display filter, and this tap will only get invoked, or really this packet function will only get invoked on packets that have an IP layer and whose IP addresses, either source or dest, match in this subnet. And so that's kind of a cool feature of listener taps. Unfortunately, with dissectors, it's not that easy, but with listener taps, it is. So now on to the interesting things. Dissectors. So to decode a new protocol, we create what we call a dissector script. Now there's nothing special, it's not a different extension, it's not a different language, it's all the same as any other script. You could write one script that does both dissection and listening and file reading and everything else under the sun. There's nothing special about that file that's different. It's just what we do inside of it. And of course, dissectors are most popular because they're for handling new protocols and let you create new fields and things. As I said, there are two ways. There are two ways to dissect packets. One is you can register a new protocol on top of another layer and register it for a number. Like a lot of people write a protocol for UDP or TCP for a specific port number in UDP or TCP. And so they'll register it into the UDP or TCP table for that port number, which means anytime that Wireshark receives a packet that has a TCP layer that has a source port or a dust port matching that number, it'll invoke your dissector. The other way is you can register it as a post dissector, which means it gets invoked after every other all the other dissectors on every packet. And there's actually a third way now, which is a heuristic dissector, but I'm not going to go too much into that, other than just to say you can create heuristic dissectors starting 1.12. So to create a dissector, you actually create a new proto object, and this is where I'm going to be switching back and forth a lot. I need to figure out how to make this a lot better than this way. This is our file, which actually does fit. Excellent. This is our very simple dissector. In this case, this is going to dissect DNS protocol. The reason I chose this is twofold. One is I already wrote the code earlier, so I didn't have to write more code. And two is that anybody can capture a DNS packet anytime they want. You just start up Wireshark on your laptop, go to your web browser, and go to some new address you haven't gone to in the past 10 minutes or whatever, and voila, you'll be generating some DNS queries. In fact, knowing Google, you're probably generating DNS queries all the time for all kinds of stuff, just so they can see what you're doing. Or the NSA gets that information from them or whatever. I'm pretty sure Google is just a front for the NSA at this point. It's based on a bigger file called dissector.lua, which is in the examples page, and which is on the wiki site, on wiki.wireshark.org. And that example site has, the very first thing it has called the dissector tutorial script, and you can download that file. There's a link to it right there. This is that actual file. It's the same as I showed you a second ago. There's a whole bunch of example scripts. Some of them are shown in line. Some of them are things you should download and view with a text editor. In this case, it has a whole crap load of comments. And the reason is I wrote this dissector so that it would try to help people understand. It's almost like a tutorial unto itself. And so there's way more comment that any rational, sane human being, developer person, which are two different things, by the way, would ever write into a script file. And yeah, it's super verbose. And sometimes I do things that don't make any sense just to show that they can be done different ways inside of the script. But instead of going through that monstrosity in this class, we're just going to go through this simplified version. And so you'll see the very first thing I do in this file is I create a new proto object. And it's for a variable I'm going to call DNS, because I'm super original in my variable naming schemes. And this proto, I could actually invoke it with proto.new, but the old way to do it is just call it with proto in parentheses. It takes two arguments. One is a shortened one-word name of my protocol. In this case, I'm going to call it my DNS. This word is what's going to show up in the field names. So I'll show you in a minute using this script, but in Wireshark itself, like if I go back to Wireshark, in this case, I've opened up this file called dns_port.pcat. That's exactly the file that's available in that example tutorial page. And that you can also download this capture file itself. Right now, it does not look like DNS because it's using an unusual port number. It's using port number 65333, which of course is only slightly related to the real DNS port number of 453. And of course, I did this on purpose to show how to use this class. You can see in the decoding that it actually queries for a us.pool.ntp.org, but that's not important. What's important is that we cannot decode this data right now, and if this were a new protocol, we'd want to write something that can actually decode these bytes that you see here. And so that's what we're going to do with this. So the first thing I do is I create a new proto object. I'm going to call the shortened version of the word my_DNS. This is the long version of the string, which is going to show up and display inside of the GUI. I'm then going to create some, let me go switch back to my PowerPoint. You then define the dissector function, which we'll do in a minute in that script file, for that proto object that Wireshark is actually going to invoke later on. And to create new fields, those new fields that I want to show in the GUI as well as allow the human user of Wireshark to go and filter on and see the values of and so on, To create those fields, I'm going to create also proto-field objects and assign those proto-field objects to my new proto object, which is my DNS protocol. People get confused between proto-fields and fields. There's another object type called field, which is different. The field object is for existing, pre-existing, either already written C code or already loaded with another Lua script, already existing fields, not something to create a new, brand new field that Wireshark knows nothing about. So with a field object, you can go and access the existing field that have already been determined by Wireshark. But with a proto field, you're creating a brand new field for your protocol, hence the term proto field. These proto field objects, when you create them, you're going to give them attributes. You're going to give them display names, filter names, how big they are, like how many bytes, usually like 2 bytes for like a 16-bit integer or whatever. How to display them, you can put that in those attributes as well. But they're not part of your protocols, your protos protocol, until you set them in the field member. So I'll show you this happening in the actual script. Bless you. So here are 1, 2, 3, 4, 5, 6 different proto fields. I'm creating them 2 different ways, just to show that they can be created different ways. One's using proto field new, which is a function of the proto field table. So creating a new proto field with these arguments. Another way is using the UN16, which is the specific creator of an unsigned integer of 16 bits. Yes?
Could you increase the font size just a little bit?
Yeah, I believe I can. Did that work?
Yeah.
Too bad. Ah, just kidding. Sorry?
I know, it's just me, I'm getting old.
Join the club, friend. The nice thing is I get to view it beautifully out here. So can you guys see that okay? With a very simple thing, I just set them all to be variables here. This is kind of an ugly way of doing it, and if you were to look in some more advanced protocol dissectors, there are other ways of storing this a little nicer in terms of Lua tables and stuff. But just to make things easy here, I just have 6 different variables. I create new proto fields for each of them of different types. One's for a transaction ID, because a DNS request and response always has a transaction ID, which is how DNS matches requests and responses. Here you see the field name for it, mydns.transID. In this case, I'm telling it it's an unsigned integer of 16 bits, or 2 byte, or 64K value field. You cannot set an attribute for whether it's in Little Endian or Big Endian format. Unfortunately, you do that later when you actually go and invoke this field, but for these attributes, this is the general things you can do. You can also set a table of different values for it to automatically use. The beauty of these things, though, is the reason I set this stuff up here is that later on, when I'm actually going to go and parse or decode the packet, because I've already told Wireshark what that field is, I've already told it it's an unsigned integer of 16-bit size. Or in this case, the second one, I've told it not only is it an unsigned integer of 16-bit size, but I want to display it in hexadecimal format. By default, it'll be decimal format. But here I told it I want to display it in hexadecimal format. And so when I add this, so for example, PF flags, you see down below, when I add this to the display tree, to the GUI tree, I didn't need to tell it all that stuff again because Wireshark already knew it because those were the attributes of that field early on. But again, these fields aren't actually part of my proto yet because you'll notice that my proto is called DNS, is stored by a variable called DNS, but those aren't in here. Instead, I actually set them into my protocol here, where I set the fields member of my DNS protocol or object to those list of proto fields. And again, in Lua, these just represent variables that represent those objects that were returned by these functions over here. Any questions yet?
At that point, you're not at all specifying the order that the fields appear.
Not at all. I could flip this order. I could put them in any order I
A
want.
list of things that you can use.
Yes, exactly. The one thing that's important is when I create these new proto fields, I have to do it out here, so to speak. I can't do it inside of a function because by then it's too late. These functions don't actually get invoked until Wireshark's running and decoding packets and stuff. And the registering of these proto fields has to happen earlier. So that's the only restriction. But the ordering doesn't matter here. The ordering doesn't matter here either in this table at all. The ordering only matters because I add it in a specific order inside of my dissector. Good question. Any other? Feel free to ask dumb questions too. They're all good. There are no dumb questions. So those are proto fields. And again, once you've done all that stuff, Wireshark can then use them to decode and display them with the tree item add or add little endian calls. Now the dissector function, and that's the second thing there. It's passed 3 objects, and I'll just go, it's easier to, I think, I'll just stick to this instead of going through PowerPoint slides. This is a dissector function. It's a dissector function because it is called dissector, and it is a member of my DNS proto. And I've set it as the function here. You'll notice that there are 3 arguments I gave it. I could have named these foo, bar, and zoo. It doesn't matter what I named them because they're just variable names in Lua. Now obviously, being the genius that I am, I decided to label them something that reminds me what the hell they are later on. But if I screw them up, which I grant you I do all the time, I screw up which ones of these are which ones. Usually I have to go back to the C code to remind myself, but it is actually written down in the API documentation. Also, if you go to the full dissector Lua thing, the full script that's available from that other thing, from the example website, in the comments it even tells you that the TV buff is the TVB object, packet info is a pinfo object, and root is the tree item object. Usually when I write dissectors, I just start with my example 1, I copy it over, and I just edit it. So I don't have to remember any of this stuff. But basically, what this means is that when Wireshark later invokes this actual function, don't forget, it'll invoke it because of something I do later, but when it actually does and invokes it, it passes in 3 different objects as arguments into my function. And I'm capturing those arguments, so to speak, by putting these variable names here. If I got rid of the name, like if I did this, I would not be capturing the 3rd argument. It's okay, it's not a programming error, I just wouldn't be able to access it later. Oops. Now, for the first thing I'm actually doing in this dissector function is I'm actually going to set the column information. In Wireshark, when you're in Wireshark, these things that you, so this packet table, packet list on the top shows all the packets I'll capture. In this case, there are only 2 packets. But each of these are a column, right? You can click on any of these as columns, and they actually are column named what they are. So you'll notice that there's one column called protocol. Right now, protocol is set to be the word UDP because that was the highest layer protocol that decoded it and set that field. In my case, I'm going to decode this stuff that's inside of UDP, and I don't want the word UDP to show up here. I want the word MyDNS to show up here because MyDNS is the protocol that's running on it. So I do that by getting the packet info, which is that pinfo object. And if you're wondering what the heck a pinfo object is, you go right on back to the API documentation, and I think I even geniusly put this up here somewhere. Did I? No, that'd be way too smart. Thought I did. Yeah, let's do it again. pinfo, whoops. This is the pinfo object that's passed in, and it tells you a bunch of fields that are accessible from the pinfo object. So you can retrieve like whether it's been visited before in terms of that packet has been seen, has been executed before or decoded before. Its number, meaning its actual number in that list. So if you go back to your Wireshark, you'll see there's a number column that's 1, 2, 3, 4. Well, that number is available to your script, to your plugin as well. The length of it, the captured length, and the reason there's both of those is because there's the length that it was on the wire versus the length that's actually captured by Wireshark. Most people have those 2 values be the same, but if you run capturing a Wireshark for a long time, that's going to end up being a very long, big file. And so a lot of people will set what's called a snap length, which means that they'll capture only a small portion of the packet. And that means that the captured information that's available for your plugin is only a smaller value than the entire original length of the packet. So usually I use Kaplan as opposed to length. An absolute timestamp, a relative timestamp, a delta timestamp, and there's a whole bunch of other information that's available from the pinfo. One of those things happens to be the column information that's shown in the GUI. And one of the columns that's in the GUI is called protocol. It happens to be the same exact one that's protocol on here. And I'm going to set that protocol to be the string MyDNS whenever I decode this as MyDNS packet. Then I'm going to create a local variable called packetlen. In this case, I could have gotten that length information from the pinfo. I can also get it from the TV buff. The TV buff is that first object that's passed in. TV buff or TVB, really, it's a TVB object. Stands for testy virtual buffer, but effectively it's the buffer of bytes that represent that full frame, that full packet. You can get any one of those bytes that you wish, but normally people only access the fields that they want. And that's another object that's available, again, with a whole bunch of functions or methods in the API documentation. And then what I call root here, sometimes people call it tree, but I use tree for something else. Root is the root tree that's displayed in the GUI in the display window. So if you go into here, the decode window, this information is actually a tree. And you'll see like this is a child, all these things are children of the tree that's called the Internet Protocol here, which is a child of the root. And in my case, we start with the root, and I can add a my DNS tree item to that, and that's in fact what I'm going to do in a minute. And that's in fact what I do right here. If you go into the API documentation for tree item, which hopefully I did put this in somewhere. Should have put this in some actual order that I can remember. Here we go. Tree item. Tree item's an object, again passed in as the third argument in my dissector callback, and you'll see that one of the functions that, and it's actually a method, it's used with a colon as opposed to a dot, it's a method of an object as opposed to just a static function, is the ability to add members into the tree. And one of the things I can add into that tree is either those proto fields that we described earlier, or I can add in the actual protocol, the DNS protocol. And the only advantage of adding the protocol is it means that my entire protocol covers this part of it. It's going to create a subtree here. And I'm going to tell it that this is the range of it is from the 0 all the way to the end of the packet length of the TV buffer. What is this going to do? You're going to sit there and say, well, I've already lost you. So let's go stop with this and start again. In this case, I'm going to invoke Wireshark I'm going to read in the DNS port, that same packet capture file I saw a second ago, and I'm going to load up the Lua script that we're looking at right here, simple_dissector.lua.
Do you have to restart X11 in order?
I do not, only Wireshark. Good question. And with Qt, there's no X11, which is the lovely thing about Qt, but anyway. Now you'll see that it's loaded up my script. And so now what's shown up in the protocol column is the word my DNS. And what showed up in the tree list is something called my DNS protocol. Where did I come up with this string? It came up with that string because that was the string I gave it back here when I created the protocol. And this protocol is what I passed in to the tree add command at this point, really to the root of it, which is why I always call it the root to myself, to remind myself it's a root. When you call add on a tree item, boy, I'm running way out of time. I thought this would go a lot faster. It always does in your mind, you know. When I call add, it actually returns the subchild of the tree. And so when I do a local tree equals this tree object, this variable, is actually going to be the subchild that's added to the root. And so from the GUI perspective, it's going to be this stuff down here that I'm going to add on. It's created this my DNS protocol as a tree item for a protocol. And the thing I'm using now from here on is just the tree object that was added back into it. And so now I'm going to add onto that subchild, in this case, the PF transaction ID, which was the proto field for this stuff. And you'll notice that I'm giving it the number of the bytes from the TDB, from the buffer of the packet that it covers. In this case, so when I transaction ID, it automatically knows to decode that as a decimal because that's the way it was defined earlier. And you'll see it already highlighted those first 2 bytes because I told it that it's going to be the TDB range from 0 to 2. And because of that, it highlights those 2 bytes, it decodes them as decimal, and it shows them in this tree. And when it's highlighted, you'll see at that bottom, that it even calls a transaction ID on the left, and it shows me that the field name is my DNS.transaction ID. All that stuff came from that registration attributes that I created earlier on in the plugin. Likewise, the flags field, which for some bizarre reason is not highlighting. Why is it not highlighting? Now we can go troubleshoot. Where is the flags field? Flags. Oh, yeah, why did I do that? I have no idea. Let's try that again. And now you see why it's a little annoying to restart it. Right. Now the flags field, which also came from those two fields for whatever reason, and I don't know why, has flags in hexadecimal because that's the way I registered it as. And in fact, it really should have been another bug. It really should have been 2 to 2. Where was it again? It's right here under my cursor.
Yeah, they're all, it starts with 2.
Yeah, well, too bad. I wonder if that's actually a bug in the original dissector though, because all I did was copy over directly from it. Interesting. So let's go change this again. Voila, it's now highlighting the correct field, the correct bytes, and it's showing the correct hexadecimal value. And again, it's in hexadecimal because my PF flags up here told it that it wants to be displayed as hexadecimal. By the way, this field in the middle allows you to pass in a Lua table that represents a bunch of values for you to show. That's shown in the actual dissector Lua script if you download and go through that. And I really do encourage you, if you're going to write your own dissector, it's going to take you a couple hours, but just go through this dissector. Just read it. You don't have to execute it or anything. It's pretty self-explanatory. And so you'll see I added a whole bunch of rest of the stuff. The ranges, so out of the TVB, this is the starting offset byte, and this is the length. The second field is length. So you notice that all of these happen to be 2 bytes long. In this case, this bottom one is purely to show that I could be crazy. It happens to create a TVB range of starting from offset of 2 of length 2, and then it creates a range of that and a range of that again. There's no need to do this. This is just done in the dissector Lua script because it's just to show that it can happen. Again, things aren't completely logical. My goal with the dissector Lua script for DNS was not to go decode DNS. We have a very good DNS dissector written in C code in Wireshark. I don't need to recreate it. It was really just to help people understand how this works. Lastly, I returned the packet length because I've dissected it all. You don't have to do this part, but I recommend doing it. It's good practice. The new dissector model is supposed to look for this value. In truth, for Lua, because it didn't require it at the beginning, we kind of don't require it still now. But when you're doing things over TCP, it becomes much more important. Before it went way out of time. The last thing, so far, if I didn't have this last line, this script would load, but nothing would happen. Because Wireshark would never actually invoke the dissector because it would never know when to invoke that dissector. All it knows is I've created a new protocol called myDNS with a variable called DNS. And I created a dissector function for it, but I've never told Wireshark when I want it to actually be invoked. This last line does that. What does this last line do? First of all, it gets a dissector table for the UDP ports. This returns literally an object again. Everything's about objects in our Lua API. It returns an object which I can add on to it. So think of it like a table. It returns an object where I can access every single registered protocol for the UDP port numbers, all UDP port numbers. Source or destination doesn't really matter. And in this case, I want to add for port number 65333 the protocol that's represented by my variable here called DNS, which is the one up here. Now, the important thing is I actually have this as my last line. The reason for that is because, again, Wireshark actually executes this entire thing at the beginning. And by the time it gets to this last thing, when it executes this had better be a fully formed protocol, including having a dissector function, all the other stuff. There's a bunch of error checking that occurs when I add this. And so that's why it needs to be last. Now, I can unregister it later by getting that table again and calling remove, or maybe it's called subtract. I can't remember. It's something weird from that dissector table. And I can do it on and off the whole time. I can also just go into my dissector function and just do return true by setting a preference and adding a variable and checking if it's true, then returning true, for example. So there's various ways of turning your dissectors on and off. I prefer add and remove them, but it can be done either way. And you don't have to have this number be hard-coded. You can have it be a variable that's set by a preference. So if you look in the real dissector, in here, you'll see that, where is it? It's actually set in some default information, default settings, somewhere or other. Yeah, default settings port, where I actually let it be changed through arguments passed into the function in this case. This script happens to be used in our test suites for Wireshark, and so in our test suites it's easier to just pass in arguments in the command line, and this happens to pass in arguments in the command line for those port numbers. Any questions so far? Yes.
So about this last line of the table, you can still run decode as, select this sector.
You could still run, yes, decode as, yes, you could. That's true. Oh, wait, is that true? Yeah, although there's some bizarreness to do that because the decode as expects different layers. So most people add it to the UDP table if they want it to be accessible. The UDP decode as, for example. You can just add this even now, even without this port number. I can add it and do it as decode as with this. But I think there's some weirdness if you don't either do this or register it as a post dissector or do something else. It's going to be a little odd, but it should work. I don't never do that myself though.
So
Give it a try.
It's registered anyhow.
I'm sorry?
It should be registered anyway, and then you can use it.
Yeah, in the code itself, it actually adds it to a table, and I believe goes through. Although I'd have to check the C code because I haven't done that in a long time.
Well, because there's nothing up there that tells it that you're working with a UDP packet. So if you just right-click and decode as, how does it know at what layer to try to inject?
It won't for UDP unless you actually add it to the UDP table, even without the port.
Yeah.
You could add it to a UDP table. But it may be able to do it as like a raw level, you know, the link level, or whatever they call the basic one. I just can't remember, honestly. If you shoot a question onto ask.wireshark.org, I could put the answer there after I look it up in the C code. Or, honestly, just try it yourself.
What if you wanted to decode something that runs on top of HTTP?
Yeah. So it actually turns out to be a limited number of things that you can add it on top of. That you can, add yourself to. With HTTP, and again, I'd have to look at the code itself to figure it out. With 1.99 or 2.0, there's a lot more introspection, I call it introspection available, where you can actually, in Lua, write up something that will actually print out every protocol that you can add yourself onto. HTTP is probably one of those protocols because it's such a super common one to decode, but it's definitely not the full 1700 or whatever number of protocols there are. And we're always getting questions about, well, can I add a Lua dissector that only sits on top of X? An variable that requires me to go in and edit the file to make that happen.
So if it doesn't, then you have to do the first part yourself as well.
Yeah, otherwise you just register yourself onto the post dissector or do the entire sublayer yourself, which is super painful. I know it's super painful. But like, for example, RTP, I don't think has one for codecs. Like, you couldn't write a codec decoder. I think it was one I came up with last year as a problem I had. And I can't remember if I fixed it or not, because it was like a year ago.
It's probably, if you're familiar with the C code, it's probably not a big thing to.
No, it's not hard with the C code, correct. Yeah, it's not hard. It's just, unfortunately, it's just not automagic. Any other questions?
If you have a protocol number which changes every day, you have to write the particular port dissector or heuristic method?
It changes the port number every day.
Yeah, for example.
I would write a heuristic dissector.
Okay.
Heuristic dissectors are just like a normal dissector, except that they return like true or false as to whether it's for them. And then they register a dissector function as well that actually gets invoked if it's for them. So they're a little more cumbersome. There's one example file on the wiki page for that. Before we run out of time, yeah, go ahead.
I was just saying, for something like that, would you ever use or have you seen anyone do this or would recommend just have that Lua file that go and maybe you've got like an INI file or something and just today here's what the devs gave.
Yeah, you could do that. You could absolutely load another file during your Lua script and go read it and then set your own variable.
Here's how long this field should be.
You could also take in a command line argument so that they can start up Wireshark or whatever with a command line argument for today's port number. There's a whole bunch of things you can do that way. You can let them set a preference. You can just let them decode as whatever. Before I know we're out of time, you can feel free to leave it. I don't care if you guys want to leave or whatever. But very quickly, there was a question about TCP dissection. So TCP dissection is really hard. There is an example file for it online. I'm going to probably add another one because it was confusing people. But the hard thing is that your dissector has to be able to handle the fact that if there are multiple of your messages inside of TCP, one TCP segment, you have to invoke your own dissector yourself, unless you fall into the fall into the concept of a very simple dissector where you have like a length field that's encoded at the beginning of your message type, then you can use a simplistic format function for decoding yourself. But otherwise, you have to do it all by hand, which is super painful. So you'd register the TCP port number you expect, and then you just have to deal with the fact that there can be a partial message, a full message, and then a partial message, 25 full messages and a partial message, whatever. You can, don't forget, you can even start capturing in the middle of a TCP connection. So they could have already been exchanging back and forth, and you could be starting in the middle of your message, etc. Unfortunately, or maybe fortunately, the C code has to do the same thing. When we write HTTP dissectors or diameter or SIP or whatever, they have to be able to start decoding in the middle of a packet and recognize that. And usually that's when you see something called continuation, because they just give up pretty quickly, and then they keep waiting until they can find the beginning of a message at some boundary of a TCP connection, a TCP segment. So new stuff in 1.12. These slides, I think, are going to be available, yes? So you can just go through these yourself, because there's a bunch of new stuff in 1.12. They're all listed. There's heuristic dissector support. There's 64-bit integer support. There's struct library, which is a very common Lua library that's available now. There's true regular expression support. So Lua as a language does not come with actual regex internally as supported. It has a pattern matching language, which is very simplistic, but an actual real like Perl style regular expression engine does not come with it, but it does in Wireshark now. So it actually comes with PCRE, the Perl compatible regular expression engine. It takes command line arguments. You can do custom file format reading. You can view file metadata that way, and there's a bunch of test suites. And in 2.0, with absolutely no guarantee that any of this shows up in 2.0, but maybe, we may support Lua 5.3. I'm not a huge fan of 5.3 myself, but apparently it's going to be supported by some operating systems by default, which maybe we have to do it. And if we do that, we may have to remove the Lua bit-op library, but I hope not. There's a bunch of more introspection of stuff. The Lua GUI, as I said, is not available in the Qt-based, derivative, but hopefully it will be by then. And my stretch goal, which basically means it won't be available in 2.0, but maybe right after 2.0, 2.1, will be to expose some of the graphing library to Lua so that you can create your own graphs, which would be a really nice feature. Because people constantly have like some enhancement requests to edit a graph slightly in Wireshark. Yeah?
Would it be possible with Lua now, with the current versions, to write to an arbitrary HTML file containing SVG or something like that, and build your graphs in that one? So let's say
You could save to a file, and you can expose a URL that can be clicked by the user.
Yeah.
And so it could be file ://
Yeah.
and to that file. And so they could do it that way, but it's hokey. But yes, of course, you can also use third-party Lua libraries from Lua itself. You can import them as long as they're on the system. So there's already a SVG is a bunch of graphic libraries exposed for Lua. But of course, the downside with that is if you give that plugin to other people, they have to install that library too. I mean, it's not like those libraries exist on every platform. Whereas with Lua, for example, they don't have to install Lua because Wireshark comes with Lua. And so that's the one downside of using anything but the libraries that we already natively support means that anybody else who wants to use your plugin has to install that library too. Or you can ship it with your plugin. I mean, that's up to you. Bless you. Any other questions? I'm sure you must have questions. I explained everything in an hour and 15 minutes. All right. Have a good dinner.